So I'm Márton Horváth. I'm working for BirdLife Hungary, and I am leading the species conservation department there. And now I will present the work which we done in the last years. Just give a short introduction about the history of our work against the electrocution and collision of birds in Hungary. It has quite a long tradition. First documented cases occurred already 40 years ago, when my colleague János Bagyura found several carcasses in the Hungarian plain areas. Of course, the problem was already there for decades, just nobody was working with it. And as a very first solution, my colleagues started a so-called cross-arm insulation program, which was running for more than 10 years or even almost 20 years. Which was a very simple and relatively cheap tool to cover the cross arms of the most common pylon types in a relatively large scale, according to the available budget those times. This program was more or less successful, especially on the most common normal types of pylons, but of course it was not 100%. Many further fatalities occurred on these so-called insulated pylons or cross arms because of technical problems and because of the different pylon types where this solution was not suitable. And of course it was also temporary. The materials were not always well fixed, and they're deteriorated relatively quickly. It means that there are some which are there for 20 years and still working, but anyway, it was not a perfect solution. But that time it was quite successful. Just a remark that it was very funny to see in a conference that after several discussions to decrease the problem of electrocution of sakers in Mongolia, a very similar solution was found out to get large-scale result with a relatively low budget. So we have started our first Imperial Eagle live projects in 2003, and our team started large-scale national service. We did a lot of efforts with the MME volunteers and with the ranger service. All of these data are published in the Wilson Journal of Ornithology, so if you are interested, it's available. I will not go into the details. Important step was in 2008 when Accessible Sky Agreement was signed by the Ministry of Agriculture in Hungary, the electric companies, and MME. It was a voluntary agreement. It sounds very well, and still it is referred as a very good example, which is definitely. But anyway, it should be noted that it was primarily a political initiation. It was initiated by a member of the parliament, and the problem was that it was very shortly done. It declared that the whole problem should be eliminated by 2020. So there was no real planning before this agreement, and the objectives were absolutely not realistic, which of course happened, as we saw looking back for the last 15 years. Anyway, some other type of works could start on the frame of this agreement, and one of them was this this preparation of the conflict map, which was firstly done in 2008, and in that year it was a very important step also that they changed the nature conservation law, that in Hungary all newly developed power line sections must be bird friendly. So most of our conflict mapping is focusing on the already existing power line sections. So our map is not primarily not to have the future development of power line sections, because theoretically and fortunately also mostly in practice they are bird friendly, but much more for the mitigation measures of the already existing grid. So the methods very shortly. So the base was the distribution of priority bird species. It was good to see the previous presentations. We did independently our method, but there are many common ways how we did it. So the distribution of the priority bird species was the main base layer for this model, because the known mortality data is highly dependent on the local effort, so we don't have a national coverage. so it is not really suitable for spatial modeling in a national scale, but it is suitable to estimate the magnitude on each species which are affected. And also it's very good to get some detailed analysis on the microhabitats, on the pole structures, and the mitigation measures efficiency. So if we go through these steps, this first step will be the longest, about the distribution of priority species. So it has 3 sub-steps. So first is to select the species which are affected and give a relative weight to each of them. So which we did is that we did this evaluation based on the conservation status of the species, from the globally threatened to the not protected species in Hungary. And on the other hand, we had the relative effect of the power lines on the population or on individual levels. And we scored from 0 to 5 all species of Hungary based on this thing. I don't know, probably you cannot see. So these are the species which were selected. Altogether 19 species were selected based on the available data sets. The red kite, imperial eagle, and saker falcon, and the eagle owl became in the first category. I will not list all the others, but it is important that 3 of the species has no national databases, and they are quite rare to use the common bird monitoring scheme, so we couldn't use reliable national maps on them. This was the barn owl, the European goshawk, and the Ural owl. So these 3 species were not included in our analysis. And regarding the collision, we had a much more simple case, partly because we have very limited data available. So we, of course, we included absolutely the great bustard as the main priority. We also used the European crane and the white stork as important species which were affected, and we used the common category for water birds and shorebirds, which we included with an average weight of 3 in the analysis, because we have quite good data on the number of water birds in the habitat. In the second step, we defined the distribution of the selected species. Here we use the databases of MME, which are developed in cooperation with the National Park Directorates of Hungary. We have a general bird atlas program, which are collecting data on all species. We have a common bird monitoring, which are focused in smaller areas, but it collects data especially on the common species. We have a water bird database, and we have many species-specific databases, especially about the rare species, where the breeding or the observation of the species are collected in GIS systems. We use the 2.5 to 2.5 UTM grid cells as a system. It is generally used by MME for monitoring purposes. It means that there are a little bit more than 15,000 UTM cells in the country, so it's quite precise for this kind of analysis. And we set 5 categories from the not significant to the most significant habitats for each species. So altogether, we put together these 19 maps for each species and for the group of the water birds. And then we made, as a final step, a cumulative priority map. For the species, here we use the sum of the probability values for each species, which are multiplied by its relative weight, which I showed you. It's the same for both electrocution and collision, just fewer species were used in the collision map. And this was the final map which we got for electrocution. If we compare it with the 2008 one, we can see that it's more detailed, and it reflects several changes in the distribution of some priority species. So there are some areas which became more important and which became less important than 15 years ago. And it's the same map for the collision, which are a bit different. And here we can see that it became much more precise than the previous map, which was based on very limited amount of data. And if you go for the next step, so this was the distribution, and now as a second layer, we use the microhabitat around the power lines. Here we could use this National Ecosystem Service Mapping and Evaluation Project result, which has a very good 20 to 20 meter quadrats for whole territory of Hungary. Here are some pictures in different zooms. So here you can see that if there is a forest somewhere, then there are different types of forests in this map, and we could group it into 6 main categories. from artificial agriculture, grassland, forest, wetland, and mixed type of habitats. So we could put all cells into these categories. We used a 50-meter radius around the pylons to delineate this microhabitat, which is affecting the chance for electrocution, because of course it depends on the given habitat, not only the distribution of the priority species. Here are some examples. We have a colleague called Peter Todt who did a lot of surveys. He surveyed more than 13,000 pylons for more than 24,000 times in this particular area where there are different type of habitats. And this database was used to fine-tuning this kind of data. For the collision, unfortunately, we have no such data set, so we couldn't use this, make this step for the collision map. So here you can see that the grasslands became the most important habitats based on the relative risk of electrocution, followed by the wetlands, agricultural areas, forest and mixed habitats were less important, and of course the artificial landscapes had the lowest risk according to the found carcasses. So, and as a last step, we used the applied bird-friendly solution categories. Here we have very limited data. There was a specific project financed by the Ministry of Agriculture to collect all available data. Here we found that my colleagues did 5 categories from the non-mitigated power lines. In many cases it means that there could be some mitigation measures, but we had no data about it because it was done by the electric companies and they are not always have a good registry on this. Then followed by this cross-arm cover, which was used in the past, then various solutions with limited precision, then the best known mitigation measures on an already existing dangerous pylon, and we used the new bird-friendly pylons as the first category as the lowest risk. Here is the map, which looks very bad according to the data set, but as I mentioned, there are surely significant gaps in the database, but anyhow it is visible that there are some areas which are very high priorities for bird conservation, which are already seems to be very bird friendly. So altogether we put together these final scores as a multiplication and we could get a very fine scale for each pylon, which theoretically could be from 1 to 2,500 for each pylon. Recently, because we have no good data from the electric companies on pole types, it's only from 1 to 500. And for the collision, we have only data on the bird priority, so we used only that recently from 1 to 7. And we could turn all this back to single pylon level. So theoretically, we have a categorization for each pylon of Hungary for more than 700,000 pylons. But as I mentioned, this data is not incorporated in the own database of the electric companies yet still. So this is our first step to be solved because otherwise it is used in a large-scale planning but cannot be used in a pylon level. So that's all which I wanted to say. As I mentioned, these 3 Hungarian DSO companies were financed this revision of the conflict map, and also the Ministry of Agriculture, and I thank all the collaborators who participated. Thank you.